Ladies and gentlemen, a name reaction I actually like, I hinted at the other day. We're going to go to Word first. The only thing I like about these people putting their name on it is the sound of their names. It's just a personal thing. Tiffeneau Demjanov. It's very poetic to me. So what do we got? We have setting up the Tiffeneau Demjanov is first. Formation of a beta hydroxy primary amine. It is that specific, everybody. If you don't have a beta hydroxy primary amine, you're not thinking about a Tiffeneau Demjanov. Okay, how do you make a beta hydroxy primary amine? Hydrogen cyanide did it for us way back in chapter 16.3. Cyanohydrin formation mechanism. You can review that one because it might show up on a test. And then, yeah, you can reduce a nitrile in, well, I should have put a section number there. Nitrile with H2PT makes a primary amine. You could have used sodium borohydride as well, or lithium aluminum hydride. And look at that. You got alcohol on a position 1 away from the amine position, which makes it a beta position to the amine. That's what beta amino means. Beta hydroxy, beta to the amine is a hydroxy. And you're going to make a diazonium ion, and then it's going to rearrange. And look at this, you know, I like this one. The ring got bigger. Yeah. We're actually coming full circle in our mechanisms. Way back, we've made mechanisms before where the rings got bigger. Like those carbocation rearrangements from the squares, you know, that one was my favorite for a while. Well, now that's my new favorite right here. Another way to set up a beta hydroxyamine is to use a nitroalkane and a base and do this to make a nitroaldol product. There was another name, there was a name on this one too, and it was kind of a nice name. There was some French in it. I believe Tiffeneau might be French too. Demjanov, he said, I don't want to go there, but maybe a Czech. Back in the day, I can't remember. I'm sorry. It could be Russian. Could be Russian. Yeah. But anyway, the Frenchman who did this, we did this the other day, guys. The nitroaldol is also known as which reaction? My lab students didn't get it yesterday. It's the Henry reaction, spelled Henry. Ah, yeah. So we got that going on. We'll have that on our activity. And then you can just reduce the nitro to an amino, and we had like 4 ways to do that. We have to learn for our test. And then the Tiffeneau Demjanov. How's Tiffeneau Demjanov work? Well, I'm not even going to talk about going all the way to here because that's what we just did. Making the N-triple-N, we will do it again. No, we won't. We're going to see activity 1. That's what we're going to say. So we're going to draw this intermediate and say C activity 1. And then, hey, it's got an exceptional leaving group. It's got an alcohol here. So if you break this bond, you make a really stable carbocation. Why is this carbocation really stable? Don't talk to me about hyperconjugation, please. It's irrelevant here. Yeah, it's got lone pairs on O that can resonate. In fact, this mechanism has this sigma bond coming in and then resonating, doesn't it? Yeah, resonance helps cations a lot. So I think we're ready. The secret is to stop the share and start the share in the right spot. There we are. We're here. May have forgot to do that on our first activity. And let's see, what's special about this? You just think of this as nitroaldol, the Henry reaction. Henry. Et sur le maison. What's that say? Henri is in the house. Okay, I don't know if that's the proper way to say it, but you know, as Canadians, they forced us to do 13 years of French, and some of it sticks. So that's an alpha position is all I was talking about. Because it's like a nitrogen version of a carbonyl. And one away from that would be alpha. And guys, I'm just reminding you, because we did this on Monday, that pKa is 10. That's pretty easy to get at. Yeah, I crossed my K off with a K. Okay, here we go. You're setting up the nitroaldol. Here's your enolate. You get your NO2, carbon with lone pair, ethyl, and enolate. Red first. Red first. You're going to attack the old carbonyl. Get a O minus. What's the O minus going to do? I think we're going to be done if we do 2 steps. That's great. I'm going to grab the H from ethanol, right? See if we can sneak the green in down here. There we go, right onto the O. That's done. Then we need reagents only for the next one. I like H2PT, but I don't like it. Oh, he's so mean. I don't like it for this particular example because there's an alkene. That's your safer bet. She's changed her mind to lithium aluminum hydride. It won't touch an alkene. It'll attack almost anything else. In fact, a good generalization for when does lithium aluminum hydride work in a reduction? Any, not with an alkene, any polar functional group that has a pi bond. How's that? So you got a carbonyl, it's going to work. That's polar. Got an N double O, that's definitely polar, right? Especially when the N has a plus charge and an O minus next to it. That's polar as polar can be. And you've reduced your nitro to an amine. And now it's I'd like to point out, it's a beta hydroxyamine. What are they candidates for? They're candidates for the world famous Tiffeneau Demjanov Rearrangement, which you have to set up first. I'm going to say C activity 1 right here. And that gets you to here. Right? Saved a little bit of time. You got to do that mechanism at least once on your test, or else you're getting 0 points twice. Okay, lone pair on N. I'm going to scribble off one of the H's. Or maybe I'll leave it on this time. I'm going to do it the way that's closer to the textbook this time. And maybe you like this way better. I'm just going to do, it's going to be more one step at a time kind of thing. Some people like that better. And here we go. Attack the N triple O and just put a lone pair on the O. And you're going to get to here. I'm going with black. And blue. There's your N. It's got an ethyl here. Still got 2 H's. Gonna have a plus now. So that's different. Got an N double O on there. Remember, you got to get to N triple N. So you got at least a couple steps to go because you got 2 H's in the way and too many bonds from nitrogen to oxygen. So tautomerization time. We can use the Cl minus HCl combination if you like. HCl here, Cl minus here. Base grabs which H? Nitrogen. Sigma becomes the first pi. And protonate this O. It's not leaving, so you didn't really have to do it first. There you go. And that's straight up tautomerization. And you have O, H, N, double N with an OH on it now. N with an O bonded to H. I have to get to N triple N, everybody. You gotta get to here. And I have a methyl missing. And another H on the end, is that what you're saying? Yes, I do. And I lost a methyl, which I'm putting there. And N with 4 bonds now, plus charge. Yeah, you gotta be careful with me today. Gotta get to N triple N. And water. Talk to me. I think it's gonna look a lot like what we just did. I strongly suspect you're gonna prefer this version over the one on the previous activity. Because these two steps look a lot more similar now. This step is looking a lot like the previous one. I hope you see that. They both use Cl- to grab an H off of nitrogen with a plus charge. They both made a new pi bond in the next arrow. They both involved oxygen getting a hydrogen. This time you just put an H on the O. This time it had to leave. I would accept and be happy if you did this arrow first with a lone pair on O to protonate the O first. But you can go straight with this one because I'm telling you it's okay. And I got one small error on this guy right here. Nitrogen with 4 bonds is not neutral, right? Yeah, thank you. And the methyl, thank you. Whoa. It's not letting me write a methyl, it just wouldn't let it. Okay, here we go. And I think we can get to our final products from here. Shall we take a look at how the rearrangement goes from our textbook? I'm going to do that. And that's under Word, which is right here. So what happens in the book for the Tiffeneau Demjanov? Where are you, Tiffeneau Demjanov? It's got to be here. Here's your N triple N. Here's your alcohol. There's 2 steps here, but one's acid base at the end. You know we're going to combine these now. So how does the rearrangement work? You break one of the bonds from the alcohol carbon to an adjacent carbon. You break it, and it makes a bond from carbon to carbon outside here. And that's why your ring got bigger. Left behind a cation, and then the Cl- grabs the H. So we're going to have step 1 in red and step 2 in green, right here. We can do that, right? And I picked a molecule here that was symmetric here, so these carbons are identical. But in your example, we had one carbon with a methyl that I kept forgetting to draw, right? And that made it different than the other carbons. So 2 possible rearrangements. We need 2 versions of our N triple N. So stop sharing, share back. You're going to need 2 copies of this, and you're going to go straight to the products. We like that. 2 copies of the same molecule. I don't write plus. They're the same thing. At least I hope they. Why not? The rearrangement happens first. You know what? Yeah, we had a problem all the way along. There's a C. I lost everything here. Okay. I tell you, this is just one of those days. There's a C here, correct? And there's two things on that C. Ethyl, right? And nitro, but nitro became N-triple-N. So I think we're back on track. Okay? All right. It's just not looking very pretty right here. But the thing is, you rearrange from adjacent bond and kick off the leaving group. That's the Tiffeneau right there. And then the other adjacent bond. And we kick off the leaving group. I want to make sure those arrows are clearly starting at the middle of bond. Yes, goes to a carbon. Yes, becomes lone pair. Yes, goes to a carbon from this bond. This bond becomes a lone pair. And they won't give the product, they'll give a cation. So you would have resonated and then deprotonated, or even better, you're going to take Cl minus and finish off these mechanisms right now. Grab H. And you're done. Grab H. Careful with this one. Becoming a carbonyl. And you're done. Which product does the one on the left give? I'm sorry that I kind of adulterated my molecule up there. So in this one, you get a carbonyl adjacent to the alkene. I hope you see that. A carbonyl adjacent to the alkene. It's got to be this one, no? And would ethyl and methyl be consecutive? Yeah. This made a bond to carbon with an ethyl, and next door would be a methyl. So we're going to the first product here. And how am I going to do that? Light pink arrow. And this one would have the carbonyl, and then on the left would be the ethyl, and then the alkene. Carbonyl on the left, ethyl, and then the alkene. That's yeah. Whoa. I went to, yeah, my pink arrow didn't end at the right spot. I think I said the second product and I didn't point. Does that happen? I don't even know. Yeah, we said it. I didn't do it. Okay. It's a weird day, everybody. We'll get past it. Is there more on here? Can we let Tiffeneau and Henri and Demjanov leave the building? I think we're ready.